A fractional slot motor, put simply, is one where the slots just can't be divided evenly among the magnet poles. 12 slots and 4 poles divides cleanly, 3 slots per pole. 15 slots and 4 poles doesn't divide cleanly at all. That mismatch might sound like a limitation, and in one specific sense it is. A fractional slot motor can't use the clean, full-pitch windings we covered in the last episode. But here's the twist this entire video is built around. That limitation is very often exactly why designers choose a fractional slot combination on purpose. Let's find out why. Look at the diagram here. In an integral slot motor, every single magnet, as the rotor turns, appears in exactly the same position relative to the stator slots. All 4 magnets in this example sit at 0 degrees offset from their nearest tooth every time. That's genuinely convenient. It means every coil can hit a true 0-degree or 180-degree electrical separation, clean, full-pitch winding, no compromises. But that convenience comes with a real cost. Because every magnet sees the identical slot geometry, the cogging torque pulse from each one peaks at exactly the same instant. They don't cancel anything. They simply add together, magnet by magnet, into the largest possible net cogging torque. Now, look at the fractional slot side. Same 4 magnets, same 12 slots, but each magnet sits at a different offset this time, 0 degrees, 15 degrees, -9 degrees, 6 degrees. No 2 magnets see the stator geometry the same way. And that difference matters enormously for cogging torque, since each magnet's cogging pulse now peaks at a different rotor angle. When you add all 4 pulses together, they partially cancel each other out instead of reinforcing. This is not a side effect. It's one of the primary reasons engineers deliberately choose a fractional slot combination in the first place. It's a real, essentially free way to fight cogging torque. Of course, nothing is entirely free. Because the magnets never align cleanly with the slots in a fractional slot motor, no coil can sit at a truly ideal 0-degree or 180-degree separation either. Designers place each coil as close to those ideal positions as the geometry allows, and use a simple convention to handle it. Coils near 0 degrees are wound one direction, and coils near 180 degrees are wound in the opposite direction, since the magnet flux itself points the opposite way there. That reversal effectively shifts the coil's electrical angle back toward 0. And here's the direct connection to last episode. This imperfect coil placement is exactly the same underlying compromise as cording, just forced on you by geometry this time, instead of chosen freely. Let's pull this together. First, treat fractional slot construction as a genuine design lever, not a limitation you're stuck with. It's one of the cheapest, most effective tools available for cutting cogging torque. No extra material, no extra manufacturing steps. Just choosing a different slot and pole combination from the start. Second, remember nothing here is free. In exchange for lower cogging torque, you give up the clean, full-pitch windings that integral slot motors get automatically. And finally, notice how this episode closes a loop that started all the way back in episode 1. Cogging torque was the problem. Fractional slot construction, and the phase cancellation it creates, is one of the most direct, practical answers to it.